see the execution of the program first. The argument count should be 1 to 5. So this is it. Let's try with a valid scenario. Let's take this as a copy paste. Let's go to the terminal. Let's run the program. So this should work. As you can see, this works. But there are 5 arguments here, and it should not work. Maximum 5 arguments are allowed because there are 1, 2, 3, 4, 5, 6 arguments. This doesn't is not allowed. Let's see something in the rule 4, which says that each individual pipes should have a maximum 5 elements. So this one has more than that. So one of the pipe has too many arguments, so this doesn't work. And try this. This works. No errors, no holdbacks. So rule 3 and rule 4, they work. And for each special characters where it makes sense, it works. So we've already seen piping. Let's see the reverse piping. Let's take this command, for example, and this is reverse piping. So it works if we do this on the other way around, like a piping, word count W, we can see the same result, so it works. So append text both text files. So append text both text files. So let's have I have a document, let's see the ls. So I have a document, let's see the ls. I have here is input text and sample.txt. So for first, let's do cat input.txt. This is the first line, this is the text in here, this is the first line. And then cat sample.txt. This is the second line with Windsor. Okay, input and sample. So if we do it like input.txt and use this operator and write sample.txt. So the appended contents of sample.txt to input.txt and vice versa. So it's going to happen on both sides. So let's again see cat input.txt. So we have the first line here, and the second line is from the sample. And if we go to the sample.txt, so this is what it had before, and this is from the input.txt, the first file. So this is working properly. Counts the number of words. So this is a word count. So we have a sample.txt. So we have word count sample.txt. Word count sample.txt is 12. Still is working. Let's try an errors handling sample.txt. And if I give another file like input.txt, which should not be the case, so I have an error. Word count works for only single file sample.txt. Input.txt is invalid or doesn't exist. So this is how I'm handling this. And then there is concatenation up to 5 operations. So I don't have 5 files ready. Let's just try it with 3 files. So I have, let's see, ls. I have input.txt. So let's say input.txt plus sample.txt plus words.txt. So what it does, this is a catenation. So it's like a cat command. This will not change the folder, the file, but it will just print out everything together. So as we can see, this is the first line. The first file has 2 lines, second file has 2 lines, and my third file has 1 line. And if I go check any of these files, let's say cat input.txt, so as we can see, the file content hasn't changed. So this is like just a printf statement with everything together. It's a concatenation. Input redirection. So grab, Windsor, sample.txt. So this let's try this. So we have let's see, as we can see, this is a sample.txt. This is there, this line. So grab, Windsor, and sample.txt. This is the second line with Windsor. It has 2 lines, so grab is working and bringing only the second line. And another, let's see, the input redirection, the dir list.txt. Let's do an ls first. See, there is no directory list or any kind of file like that. So what we do is ls-1 redirect it to a new file, dir list.txt. So this should be created now. If in ls, there's a dir list. If you cat out the dir list.txt, we can see the input of ls-1. Now let's try the append function. So ls-1, because the dir list does not have itself, but it's a newly created file. If I do an append right now, it will be like ls-1 dir list.txt. It says append. Now do dir list.txt. The previous content was this much, and this is the appended content. Okay, so this is working. The conditional execution. Okay, so let's try this out. Before that, let's try the sequential execution. So let's try something simple like date, then pwd ls -1. So this is happening sequentially. This is the date. This is the pwd, the current directory, and this is the ls -1. That's pretty simple. For the conditional execution, let's try something like this. The end. We have echo something, and echo another. Okay, so this is an end condition, and both should be printed. Something and another both are printed. So yep, it says to something like echo 1 or echo 2. So in this case, only 1 is printed because this is satisfied. It doesn't go into this command. Let's try something like a negative value. If you have something just random and do it with end command, echo something, nothing will be printed because this is a failure. But if you have something like this and do an or command and echo something, the something is printed, although this one failed. So it's working properly. And let's try a bit more complex command. So this is random stuff and do an end. And let's say echo nothing because this will not be printed. Echo something. Now the end, the first part should be failure, and the last part should be printing. So something is printed. So yeah, it's working properly. So conditional execution is printed. Yeah, so that's it. The last command I'm gonna try is killterm because I want to like kill everything out. So yeah, this is killed. Let's now see how the program works. Function is an auxiliary function that checks this token is a special character or not. So this is special character function uses this token as input, and then it will check that if it's a special character or not, where it checks from here. Okay, let's just not. This is just a white space remover trimming function, which will remove the front, the white space from the front and the back, the trailing and the initiating white space. And this is a special command which I will discuss later. So let's start with the main function. The main function has the first. It starts with w25. So it's a while loop. It's an infinite while loop. It will keep printing this, and then what it does is it gets the input. So whatever I write in after the w25 shell, so the input is being taken and will be kept in the input. After that, I've read the input. I want to remove the trailing null character. Then I have something like a command count because we have like 2 to 5 commands or someplace, or even if we don't have it, command count is a very important thing. We'll just see that we have this commands array, and this array will have the values of the commands after they are tokenized, and the command count is important to access that array for a specific position. And we have something like, as we can see, let's start with this. This is starting with reverse piping. So this reverse piping, so we have a command count, we have this parse special command, and it will just parse the command, tokenize it, and return a command count, which will be stored here. So we can see this parse special command. What it does is it has a delimiter. The delimiter is inputted from here, which is the operator. So based on the operator, this will be parsed, tokenized, and after that, the command count will be returned. So pretty much all the options, all the spatial characters, they use this parse special command, except 1 or 2. I will discuss them later. So this is the reverse piping. So let's see the reverse piping first. Reverse piping, first what it does is it will try to create pipes, and if it fails, it will give an error. And after that, it will just redirect the output or input, and then we have the parse arguments. So each one, the commands array, will have multiple individual commands. For example, you have ls -1, and for the reverse output, we have word count w. So this one is one command, this one is another, but the commands array will have all of them in one array, which we do not want. And what we have to do is separate them. So this is what is happening here. We have the commands as a two-dimensional array. Two-dimensional array here will only have one command. So we have something like ls -1, and based on the white space, this is being tokenized. So ls -1 will become ls -1, and so this will be separated. We're using exec vp, which is a vector who knows the path. So it takes something like the first command and the arguments. So reverse piping and handle the piping, both of them are pretty similar. The only difference between reverse pipe and handle pipe is that handle piping goes from 0 to number of commands, and reverse piping, it just counts from in a different way. So it starts from number of commands and goes back in the reverse order. Counts, the maximum pipe is a number of 5. If it is more than 5, then this error will be shown and it won't go reach the function. This is conditional execution. I moved this one forward because so that there is no confusion with this. Because this and this, it might get mixed up. That's why I moved it forward. Then I have here is the append. So append exactly takes two files, and then there will be trimming, removal of white space, and these two files will be inside the function of handle append. Let's go see that function. So handle piping, reverse piping, and then handle append. For the handle append, we have this file descriptors open. And what I'm doing here is basically I have a buffer. The buffer, first, it will just open up this file, read the contents, and then it will close the FD1. And then it will open the FD1 as an append mode. The first time it is read only, reading the contents, and then the file descriptor 1 will have it in append mode. And then we're reading the second file in a read only mode. After that, we're just going to write everything in the first file. We are done for the first part. First file will have contents of both files. And we just close the FD step. Similarly, we just go and move to file 2, previously stored contents of file 1 to file 2. Let's see the word count next. Word count is pretty simple. We just open the file in the read-only mode, and after that, in a for loop, we count the number of words. If the file ends while we are inside a word, count the last word. So this is just one increment. Okay. Concatenation is also kind of similar. We have a file descriptor open, and after that, we just use one file descriptor for each one of them. So we have a for loop for number of files, and after that, just open up the files in a read-only mode. File has been written, read and print the contents of the file. So we're going to read it with the read system command, and we did write it into the stdout file now. So we're going to write it in the stdout. After concatenation, there is handling redirection. So here we can see that each of the redirection has different options. It can be input, it can be append, it can be output. So this is the tokenization part. And after that, we just do a brief check that no command is provided or not. And from here, we have fork. And this is the output file that is created. And this is the exact CPP command. The conditional execution part. So it has an auxiliary function like signal execute command. What it does is it first tokenizes the input command. So after the input command is tokenized, so this basically means that if you have a command like ls-1, it will be tokenized based on the white spaces. As you can see, it's tokenized based on the white space. After that, you have this PID fork. A fork will be created and exec CPP will be attempted. If it is a failure, the parent will catch the status. If this one fails, this fork fails, then it will exit as a 1. The status will be either something like 1 or 256, and 0 if it is successful, if this fork is successful. This status is important for the conditional execution. And afterwards, as we can see here, this is conditional execution. This is a loop. The input, we read each character one by one. And after, if it is reached a trailing character null value, then it will stop. The first thing we do for each loop, we're going to clear the CMD where we store all the commands. After that, this is we keep taking inputs of inside the CMD. We check three things with AND operator. 1, does it reach the AND? Second, does it find something like an AND? Or third, does it find something like OR, this OR command? So until it is successfully finding one of these, it will keep getting inputs from the input to the CMD, character by character. Afterward, we insert this, the last one. So since it will reach one of these, the operator will be replaced by this. First thing we do is we're going to execute the command. After the command is executed, for the next part, we check if the operator, what is the operator? So if it is an AND operator, we do something. If it is an OR operator, we do something else. And then if the current status is 256, the current status is coming from here. If the current status is 256, which denotes failure, if it is an AND function, we skip the next. In the case of OR, if it is a 0, which is a successful, we skip. Basically, if we have something like, let's say, command 1, and then count 2. In this scenario, if this one is failure, we skip this part. And in the case if it is or, if this one is successful, command 1 is successful, we skip command 2. And after everything is done, since we are resetting CMD every time, if there is something remaining, this line will handle it. And for the kill all term, what we're doing is we're getting the group. After we get the group, we're going to send the group stick term. Thank you.